Hi, everybody, and thanks for attending today's webinar, Testing Chef Infra Cookbooks Fast with Docker. It's our third webinar in the Chef Infra Quickfire series, Get Your Automation in Shape. My name is Raisa, and I'm on the marketing team at Progress. Before I turn it over to our speaker, I have a couple of housekeeping items to cover. If you have any questions, you can submit them in the Q&A section at any time, and they will be answered at the end of the presentation. For the best viewing experience, we recommend closing any additional programs or browser sessions running in the background as webinars are bandwidth intensive. And finally, as always, this webinar is being recorded and an on-demand version of the presentation will be available to you in the next couple of days. So let's go ahead and get started. Over to you, Tim.
All right. Hey, everybody. My name is Tim Smith. I am a product manager here at Chef Core C Progress. I'm in charge of the Chef Infra client, Chef Infra server, and Chef Workstation. And before this, I was on the Workstation team and also the lead on the Chef Infra client project. I just want to jump in a little bit and start off with a bit of what we're going to talk about today. So we're going to go over an overview of Test Kitchen, why Test Kitchen is a really great tool for testing your infrastructure. We'll talk a little bit about Test Kitchen and Docker, how that plays together and why it's a really good combination. We'll do a bit of a demo where I'll show some cool stuff and give you kind of a scenario of how you can use this all together. And then we'll take some questions. So if you have any questions, feel free to put them in the chat and we'll see what we can do. If we can't answer them here, certainly we'll get back to you. Like we said earlier, this is not our first webinar, right? We've done a few of them. If you haven't seen them yet, they are up on our YouTube channel. So we talked previously about some of the great new features in Chef Cook Style and how you can use that to keep up to date with Chef Infra Client. And we also talked about an upcoming compliance phase that we are introducing in Chef Infra Client 17. And that was our last webinar. Obviously, today, we're going to be talking about Docker and testing with Kitchen Dockin. We do have a launch event. Wow, I'm struggling here. A launch event for Chef Infra Client 17 that's coming up on April 28th. So keep an eye out for that. And then we are also looking at doing more of these webinars. They've been a pretty awesome way for us to kind of show off some of the cool stuff that people might have missed. So let's talk about Test Kitchen, right? What is Test Kitchen? Well, Test Kitchen is an independent open source project. We sponsor it here at Chef, but it isn't a Chef project exactly. It's come out of a lot of Chef developers in the community in the past. We've seen a really great set of people who put this all together. It does ship in every copy of Chef Workstation, along with a whole bunch of different plugins for Test Kitchen, allow you to use it on different clouds and stuff. And you can generate a cookbook that uses this with the chef generate command right in Workstation. So if you run chef generate cookbook, my well-tested cookbook, you'll get a kitchen file automatically that'll set you up to kind of go about testing that cookbook. And we'll talk a little bit about that later, about how you can use that, some different flags that help you really tune that. The greatest thing about Test Kitchen is it has a really extensive plugin model. And this model means that we're going to meet you where you work. Of the examples that you see often are really about Kitchen with Hashy Vagrant. That's a really great way to use it on your local system. You can use it with Hyper-V, you can use it with VirtualBox, Parallels, VMware Fusion, any of those kind of local workstation-centric hypervisors that lets you just test that locally. But it also does have support for a whole bunch of other different places, right? So if you're in public clouds like EC2 or Google or DigitalOcean or Azure, it has support to spin systems up in there, which is really great if you use some of the hosted services there. If you need to, write a cookbook that also interacts with RDS or needs to be in a specific ELB or whatnot, you can do that right there in your testing. It also supports on-prem clouds like OpenStack and VMware vSphere. Also great, again, really helpful, particularly if you don't have powerful laptops and you spin up a lot of systems, maybe Windows systems that require a lot more memory. You can offload that work into somewhere like OpenStack or VMware Cloud. And then, like I said, locally, you can run it using Kitchen Vagrant driver, which is the default driver. And that allows you to test on things like VMware and Hyper-V and VirtualBox. So there's a whole bunch of different places you can run it. But it also really is about kind of testing what you care about, right? It's not just about what hypervisors you're using. It's about making sure we actually cover the things that you have in your infrastructure. The really great part about Test Kitchen is you can set up different suites. This is a really cool way to make sure you're covering all the different scenarios of a cookbook. You might have a cookbook that controls a certain application deployment, but you have that application as both a client and a server. Maybe you have it deployed different ways in different parts of your business. You can set up different suites to cover that. And we'll talk a little bit about how you can put tests on those suites. So you make sure you cover all the scenarios that are important to your business. It also tests pretty much every major operating system out there. You can test Windows, Mac, and pretty much every Linux distribution under the sun. When you're talking about on the kitchen Vagrant side, we make Vagrant boxes for all the major Linux distributions. And then I'll talk a little bit later on the Dawkins side about how we tackle that same issue. In terms of testing the functionality we have automatic validation that occurs through Inspect. That's a really powerful tool. You get all the great features of Inspect in terms of auditing capabilities and compliance capabilities. You can bring those into your testing. So that gives you the ability, to reach out to databases, to reach out to different web servers, to make web calls, all the things that you would do when writing a compliance profile, you can also do in your testing. So you can use that same common language and write really powerful, easy to validate specs. A lot about what I've talked about here kind of is using these different clouds and using Kitchen Vagrant, but why would we want to use Docker for this? What is the advantage of Docker over using one of these more traditional clouds or local hypervisors? And it really comes down to this, right? It's incredibly fast. It's an incredibly fast way to do your development. It allows you to really get into a process where you're just kind of iterating over and over again because you can test these systems so incredibly quickly. The startup time on containers is amazing. They're low memory usage, right? You can just spin these things up. They're not going to take 4 gigs of memory to spin a full VM up. And if you're in the cloud, sometimes when you need to create security groups, you need to bring up instances. That's a pretty timely thing to do. If you're talking about on the local system, we'll show you how you can just spin one of these up in a few seconds. One of the other really cool parts about using Docker here is it's CI ready, right? You're not always going to have access to these hypervisors when you're in a CI pipeline, when you're, Circle CI or GitHub Actions or Jenkins, you're not always going to be able to spin a system up using Vagrant, or you're not going to want to put the secrets in there to reach out to your cloud because that might get compromised. Now you've got cloud keys that are out, in the public, which requires you to go through all that wonderful fun of resetting all those keys. So you can do that all with Docker. You can run this in pretty much every major CI environment. The other great part, and this is something that, as I found out as I was putting this demo together, was kind of a hidden feature, is that Kitchen Docking is super cluster ready. And I'll show off why that's really cool and why that allows you to really test the way your business uses your applications, not necessarily the way you think of them in kind of a single cookbook-centric way. So this is Kitchen Docking. It is named after the terrible 80s band. Sorry if that's a band you like. It's the chef way. We name things after really silly things. Kitchen Docking is a little bit different than some of the other kitchen drivers that you might have seen out there. Test Kitchen has a concept of a driver, a provisioner, and a transport, and that's basically how I spin the system up, how I provision it, whether that would be Chef or whatever other config management tool you're talking about, and how I communicate it with it, so SSH or WinRM or whatever. Kitchen Docking is an all-in-one driver. It does all those things, does them all over Docker, and that means it's really optimized for speed. It doesn't have to worry about getting SSH services up. It doesn't have to worry about making calls out to bring instances up or any of that. It's all just Docker, 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 all the way down for speed. It ships in Chef Workstation. So this is available to everybody. And it uses special container images that we have. So the trick you run into with Docker is that a Docker container is not a real system, right? A Docker container is meant to be the minimum amount of container packaging that you would need in order to be able to be successful with the application. We want to use this for a little bit different of a thing, right? We're not running a Tomcat site or a simple web server. We're trying to make this look like a real operating system. So we start with the base containers from all the vendors, and then we add back the packages you would need, systemd and logging and all the utilities you would need to actually be able to test these, make them look a little bit more like VMs, more like a full instance. So they're not going to be 20 meg containers. They're going to be in like 150 meg containers, but they'll still spin up incredibly fast just because of the way Docker is built. Also, to help with that speed, instead of installing the Chef client onto these systems like you would get traditionally in Test Kitchen, we're going to just connect a Chef container right in there. And that's really great because, again, we can do that, snap of a finger. We have Chef available. We don't have to go through the installation process, which is pretty quick, but that's like another maybe 10 or 20 seconds. We would wait for that. So instantly connected. The last thing I do want to mention with Kitchen Docking is that this is not to be confused with Kitchen Docker. Kitchen Docker is not Chef specific. You could use that, with other tools. It also has a lot of problems. Some of the design decisions that were made to make that really generic to work with other config management tools make it so it doesn't actually test a lot of things, particularly when you need to test services starting. Anything that's systemd. Kitchen Docking has a lot of trouble with that. Or sorry, Kitchen Docker has a lot of trouble with that. And that's why we went about creating Kitchen Docking. It's a totally different way of doing this. And we think it's a really great way for people, specifically, obviously using Chef, but a really great way for people to test full system service kind of deploys. So let's jump into a little demo here. We'll see. We'll see if I got this to work. All right. So the first thing I want to show off is how we can go about generating a simple docking setup. So we have the Chef generate command, and I have nice autocomplete because obviously I did this already. Hopefully everybody can see this. I'll pull it up a little bit more. We have a Chef generate command. If you haven't checked this out in the past, it's a pretty handy command. It ships in Chef Workstation, and Chef generate gives you a bunch of different things you can generate. So if you want to generate like your first Chef repo, or you want to generate a cookbook or just attribute file or a custom resource or whatever, you can do that all directly in Chef generate. It's really handy for generating this cookbook. It also has a little flag in here that is the -- kitchen flag right here. And in this case, we're going to specify docking. Out of the box, it's going to generate a kitchen file that's going to be a Vagrant file. That's a great way to do it, but that's not what we're talking about here today. So we will generate a cookbook real quick here. And now we have a cookbook called My Cookbook. And inside of that, we can see that we have a few files, standard stuff we would expect, kind of a policy file, metadata, some recipes, some specs, a test directory. But we also have a kitchen.yaml file. So what does that look like? Well, like I said, Kitchen Docking is a little bit different than Kitchen Vagrant or other drivers you might see. It's the all-encompassing driver. So it's a little bit different how we do the config. We do have to specify that everything is docking. So we're going to build the system with docking, we're going to provision it with docking, and we're going to communicate to it using docking. We are going to verify this with inspec. And then this is what one of our setups looks like. So we have different operating systems here. They are published to Docker Hub publicly. You could mirror those down if you wanted to, if you're worried about pull limits and things you might find on the public Docker Hub. But we do have this available. This URL here will show you what all those different containers are. So we cover CentOS, Oracle, Fedora, Ubuntu, Debian, Alma Linux, Scientific, pretty much kind of all the basic ones that you would see out there on the Linux side. And they kind of follow a pretty similar naming pattern to what you might be used to in Kitchen Vagrant. It's going to be docking and then CentOS dash whatever. In terms of the suite here, we're going to get a suite that's just our cookbook, and then we are going to do that verifier with inspec. Again, this is all pretty similar to all the other kitchen configs. This is kind of the meat of it, and we do have an example here. We will link to this at the end of the presentation that shows you kind of a more detailed example of what this file looks like and what all the operating systems would be there. So I want to show off a little more advanced scenario here, and I have this recipe called client server. I'm going to open this up real quick, and yeah, it actually popped up in the right window. So client server is a little bit of a different setup. I set up an example cookbook to kind of show the clustering capabilities and kind of the development process and why I think kitchen docking is really awesome in terms of speed. This is kind of similar to that example that got generated, except in this case, I'm only going to have a single Ubuntu system. I'm not, worried about testing every single operating system. I am going to make two different suites, and this suite is going to be a client suite and a server suite. You might notice it's a little bit weird here in the way I'm doing it. I have a run list for the server suite. I don't have a run list for the client suite. I do have a kitchen or an inspect test though, and that's going to show how we can connect between the client and the server. I don't actually need a recipe because this is an example, but in this case, if this was really your business, you would probably have some sort of client. Maybe you have like a database and a thing that connects to the database. It's your application. You want to test how that would work here. What that server recipe looks like is just an Nginx install. We're going to deploy a pretty simple website here. So we're going to run apt update to make sure we have all the package caches the way we need them on this container. Then we're going to install Nginx. We're going to drop off this really simple web site. This is like me going back to like 6th grade, HTML in 24 hours book time here. I might be missing something, but my HTML is a little dated. Then we're going to actually configure that site. Again, pretty simple site, right? We're going to drop anything in this root folder, which is where we put our file. We're going to expose it on port 80, and we're going to log it, right? Pretty simple stuff. And in the end, we will start that service up. So this will give us a nice fully running Nginx, and then we can see how this works. So bring this up a little bit. There we go. Let's take a look at what we have in terms of the kitchen config here. So we have 2 boxes that we will be spinning up 2 instances. The first one is that client on Ubuntu 2004, and then we have the server, and these are all Docking, right? Docking, and then we do have inspect tests. We're going to inspect, verify those. So let's spin up that server, and we'll see what this looks like. It is pretty fast. Hopefully this all works. So the first thing we're going to do is we're going to build that image. That's kind of a combination of a system image we have inside of Docking and an image from Docking specifically for Ubuntu 2004. I'll scroll up a little bit because that was just way too fast, which is kind of the cool part, right? That system came up, almost instantly. We connected a Chef image to it, and here we go, like boom, we're in Chef. Chef is running. We're synchronizing Cookbooks, and we're already applying config. We dropped our file off here. We set our site up here. All the configs are all in place. All the fancy Nginx stuff you need is ready. And we started the service, right? So that whole thing took 15 seconds. There's no trickery there, right? This was just a from scratch container, fully updated, installed, and started in 15 seconds, which is a pretty cool feat. Normally, you wouldn't be able to install Chef in 15 seconds. You certainly wouldn't be able to spin a VM up usually in 15 seconds. So this is pretty cool to have that part run in 15 seconds, 23-second total for the test kitchen run to do the whole thing. Not bad, right? I want to log into this real quick and kind of show off a little bit, that it's real and it works. So we can log in. This is just the same as you would do with a normal instance. We're just really doing like a Docker run, probably on Bash, I think, to get to this. But we are in the system now, so we can issue commands just like it's any normal Linux box. The cool thing to kind of show off here is actually the host file. So we set that up as server. I'll show you a little bit in the config of how we're doing this as server, but we're actually building real systems in a virtual network that we have here. One of the great features of Docker is that you have networks you can create in Docker, and we can actually name these containers. We can put them into those networks, and we can do host resolution across that Docker network. And we get that with Kitchen Docking. So now we have an actual system here set up as server. It's server local to this container, but it will be server available to the client container as well, which again is really cool. And I will show off why that's awesome. So let's converge the client one real quick, and this should be pretty fast just because there's no recipe. This is more about just spinning that system up. All right, so we got that system now, so we can kitchen log into our client instance here. And now we're in the client, and again, because we have a network set up here, this is actually named client. And you can see before we were 18.0.2, now we're 18.0.3. So we have a nice network here where these can all communicate just like there were real instances in a real data center or VPC in AWS or whatever. The cool thing we can do is we can curl that server. So that was server port 80. And boom, there's our website, right? So we actually have a client server communication here happening within Test Kitchen that allows us to test out what that looks like. And where this is cool, well, what I'm getting to here is we can actually write inspect tests to this. So we'll go and look at what this inspect test looks like real quick. I have this test integrations client folder. This is an inspect test that's going to run on the client instance. It's really validating the server, but it's validating the thing our business cares about, right? I don't care particularly that there's an Nginx running. I don't care that it has certain permissions. I mean, maybe I do for auditing standpoint, but what the business really cares about is that I have this server that works. And what I especially care about is that the client can access the server. It wouldn't do me any good if the server was up but not available due to firewall rules or something like that. I really do need to make sure that I can actually get to this from outside the world. So I want to run a test on my client system. I want to this description here is using the built-in HTTP resource. Like I said, we can use all the inspect resources, which is great. There's like 100 or 200 of them. We can check the status of that response, make sure it's a 200 code, and then I can do just a simple scan within that text to look for this content, which is going to help us when we run this. So let's run that verify on our client, and we'll see what we get back. Oh no, we have a problem, right? This didn't pass. We did get a 200 back from our status, but it looks like this didn't actually meet what we needed in terms of configuration. We got back my great website, and it was supposed to be my amazing website. So we're gonna have to fix that. And we're gonna show here how we can actually use this as part of a really tight, quick feedback loop. Because pushing out a change like that is quick, right? My amazing website is correct. The spec is correct. This is what we want, but it looks like our recipe was probably wrong. So right here where we're dropping that file off, my great website, like that was a total typo. Maybe that was the old version of our business's setup. So let's change that to my amazing website. We'll save it. Super quick change we can make, and we validated that. Obviously, if we would push this into CI, we could have run that in a CI pipeline. We could have seen this exact scenario happen. We would know instantly before we deployed it out that we had the wrong change. But we'll converge that server again one more time here. I see a question right now. What are you using to fill in that command? I already typed that command. I'm using fish for my shell, and my shell just autofills with my history. So it's not like amazing autofill capability in Test Kitchen. We do have quite a few of those. The chef commands, for instance, chef generate and everything, that'll auto complete for you. There's auto completion there for ZSH and fish and bash for you. But I don't believe we have one for kitchen. We should create that because that would be very handy. So here we redeployed our website. Again, super fast, right? Complete runtime on this, sub 8 seconds. The actual chef converge time was 6 seconds, super, super quick. And we can see it here. We changed that H1. And now we can see if our client gets that change correctly, right? This should be a really easy feedback loop here. And boom, now we have our body bringing back the expected test results, and we validate that. And we would know at this point, this was probably good enough on local development to push this up. I'm not going to embarrass myself with my coworkers with all my typos and fat fingering, missing N's or do's. I can commit this, open a PR, take it through CI pipeline, do whatever additional validation we do onto it, and push it out to production without causing an outage, without deploying my great web page by accident. So this is kind of the feedback cycle that we see here. Even if you did this without the cluster capabilities, it's a really powerful way to just quickly get feedback because you can just spin these systems up so incredibly quickly. You can build out really extensive tests. If you want to build out 10 or 20 suites, have them run all kinds of different scenarios, different ways your business deploys, some node app or some web server or whatever. You could see that in all kinds of different scenarios because it's incredibly quick to converge these. You're not going to be sitting around all day. I don't know if you can hear it, but my fan is not going that crazy. Zoom is making it a little lifting off my desk, but I'm not spinning up full system, so I'm not melting my laptop and killing my battery life. This is a really easy thing you can do with limited processor power. And then the last thing I will mention here, just because I think I glossed over that a little bit, the part that makes that actual hostname configuration happen is this part of the config right here, where I set per suite I set this driver hostname value. So if I wanted that to be like, foo, like that could be foo. It's not tied in any way to the suite name. It's just whatever arbitrary value you want to give it. And they all just show up on a flat network. So that is the demo portion. Let's switch back here. Here's some resources we have. This will be available. We'll post this after the fact. One of those is that examples line that is going to be available to you if you just run the kitchen, chef cookbook create command. But we also have test kitchen documentation, and then we have the GitHub repo for kitchen docking. I think that's a typo. That's supposed to be docking. And that has some additional information, some different scenarios. There's a whole bunch of cool ways to use this. I really scratched the surface here on the things you can do with it. Certainly didn't go over how to bring it into CI or any of that kind of stuff, but there's a bunch of great ways to use this tool. The last thing I did want to mention, we release new versions of Chef Workstation every few weeks. They come with new versions of all these tools. There's new kitchen docking updates. Just last week, we released a new kitchen docking update, and we release new test kitchen updates just about every 2 weeks. So sign up for our Chef Release Announcements channel in Discourse, and you'll always get those straight to your inbox. Just the release announcement stuff. You can sign up to each subject. You sign up to that subject, you'll see all of our release announcements. You always know when there's some new feature you might want in Test Kitchen. And with that, we can take some questions. So, Q&A. Let's see what we got. The first one, I'm going to unfortunately crush someone's dreams here. The first question is, can you use this for Windows cookbooks? You can't use this for Windows cookbooks at the moment. There is potentially that capability for us. This is very specifically to Linux. Some of the things that make it incredibly fast are that we build like a base CentOS container and do some things where we bring that chef container into it and the actual docking container. And it's very Linux specific. It's certainly something we could potentially do. There's no like real technical limiter to it, but at the moment, that's not a supported capability. In which version of Chef Workstation did Docking become available? I believe Docking has been in every version of Chef Workstation. I'm pretty positive that Docking has been around for a while in Chef DK. Yeah, it's unfortunately a little bit tricky sometimes to know what the drivers are that are available to you. There's a lot of drivers, right? Like I showed that list there of all the different clouds you could use. Those are all drivers. Those are all in Test Kitchen. We ship them all, whether you want OpenStack or Hyper-V or Vagrant or whatever, it's all in there. Does kitchen docking require that Docker is installed? Yeah, you do have to install Docker. So on my Mac here, I'm running Docker Desktop, which is just a VM, actually a Linux VM of Docker, if I remember correctly, with a nice GUI over it. But you get that in a lot of your CIs out of the box, right? So like you automatically have that when you're running like GitHub Actions. If you're in something, Circle CI or something like that, those are kind of Kubernetes based. So you're like somewhere in there as a container subsystem. You can also use this in Podman. There's some basic support for that. So really kind of anywhere you have containery technologies available, you should be able to get this to work. How does server resolve if it's not defined in Etsy host? That's some Docker magic right there. I'm pretty sure that what you get is a name server actually in Docker, and you're doing name resolution off of the Docker engine itself. Yeah, that's all Docker magic. It's not in a host file, which is the great part about it. You don't have to manage host files to make this work. What else do we have here? I like both Pliny the Elder and Pliny the Younger. They're both pretty good. That's my up there. Nice to see people checking it out. You can customize the version of the Chef client that you run on the system. So again, I don't have the full config here. The config that's actually up on our examples website, there's a part in there where you're specifying the container you want to use. Because it is Chef as a container, it's actually pretty easy. Out of the box, it just goes to the latest stable version. The one tricky part you'll get there is because Docker just caches that Chef container. If you pulled this down once, like whatever Chef I'm running with here, in 6 months, if I never pruned all my Docker containers, I would still get the 6-month-old Chef. That is the one bummer part of this. But you can specify whatever version you want. So if you were trying to test like upgrades or something, you wanted to see how something runs on Chef 14, 15, 16, 17, you could put in, 14, and there is a Docker hub tag for 14, pull the latest 14, and you would just be able to test that. Pretty similar to kind of how you do that with like Kitchen Bakery. Then one of the other questions was, is there documentation around the kitchen.yaml that we can reference to? There's some reference examples. There isn't a full documentation in terms of kitchen docking. There's a lot of documentation in that kitchen docking repo that kind of breaks down all the configs and what they do. But there isn't like a formal doc site specifically for kitchen docking. As a product manager, I can say that is a 2021 goal we have for our roadmap, is to get that. We want to make sure that all the different kitchen drivers are documented. They're not all there. Sometimes you have to reach out to the repos. In this case, I had to deal with a slight amount of digging last night in the source code. That's not the experience we want. So we're going to make sure that stuff all gets into the docs. But at the moment, the repo is a really great place to go. That examples kitchen.yaml file in our test examples repo is another great place. And when you generate one of those cookbooks, you get that test examples as a comment right in the config. So you can go bounce right out to that. Let's see. I think that covers all the stuff. A lot of them are the Windows question. Sorry, folks. Soon, I would like to do that. I would really like to make this work on Windows as well. But at the moment, this is a Linux thing, just because that's where Docker started. All right. Well, I think that is it. I want to thank everybody for coming. This was really great. If you have additional questions about this, feel free to jump into the community Slack. There's a test kitchen channel there, and there's a lot of great people that'll be super helpful. There's also sous chefs that have a lot of experience running this all in GitHub Actions. Those people can definitely help you, show you like how you can bring this into a GitHub Actions pipeline, which is a very powerful way to run this all in your CI. Make sure that you're not accidentally pushing bad changes out to production. But thanks for coming. Have a good day, everybody.
Thanks, Tim. So we hope you found value in all the information that was presented today. So if you like what you saw, we encourage you to share the presentation with your teammates and professional networks. And the on-demand version should be available in a couple of days, and we'll email you as soon as it's ready. You will be able to access it using the same audience link which you're using now. So with that, thanks again for attending, and have a wonderful rest of your day. Bye.